This is function table practice number 2. So if you have the companion resource, we are going to start on the front side, and we're just going to do one problem on the front side. We're going to spend the majority of this video focusing on the problems on the back. So we're going to do number 1 on the front side. We're going to start out there, and we are given the equation y equals 5x plus 6. All right. Now, as I did in a previous video, I'm going to go ahead and color code this so that we can very clearly see what's going on. So I'm going to rewrite this, and I'm going to do my y in red. Oh, hopefully I'm going to do it in red. How about green? There we go. So I'm going to do my y in green. I'm going to do my operations and any of my constants in black. I'm going to do my x in blue. Okay. So I'm going to go ahead and set up my function table. So my x's, or my inputs, are going to be 9, 4, 8, 2, and 6. And I know you guys can't see the 6, but I will slide it up when we get there. All right, and then there's my y. Now for each of these problems, just as we did in the previous activity in the previous video, all we're doing is for each of my x inputs, I'm simply going to substitute whatever my x input is for x in my equation up here. All right, so for this first one, y is going to equal 5 times 9 plus 6. All right, so 5 times 9 gives me 45 plus 1 plus 6, excuse me, 45 plus 6, which gives me 51. For my next one, we've got 5. We're going to substitute 4 for x plus 6. So we've got 5 times 4 gives me 20 plus 6 gives me 26. For 8, we're going to do 5, substitute in 8 for x plus 6. 5 times 8 gives me 40, plus 6 gives me 46. Next one is 2, so 5. I'm going to substitute 2 for x. 5 times 2 plus 6. 5 times 2 gives me 10, plus 6 gives me 16. And then finally we're going to substitute 6 for x, so 5 times 6 plus 6. 5 times 6 gives me 30, plus 6 gives me 36. Now this is actually one of the more challenging ones on this assignment. So if you're able to do this one and follow along, you should be able to complete the rest of the front side relatively easily. Okay? Alright, now on to the back, and I know for several of you guys this was a challenge. So I wanted to spend the majority of our time focused on the problems on the back. Alright. So we are going to start out with, we're going to start out with number 1. All right, and I'm going to skip around on this one a little bit because I want to make sure that I cover the different types that you're going to see on this particular section. So I'm not going to color code this time because I don't know that there'd be much value in that. I am going to try to fit it all on the screen at one time though. So my X inputs are 0, 1, 2, 3, 4, and 5. And my Y outputs are 0, 4, 8, 12, 16, and 20. Now, the challenge for these function tables, when we're not given the equation, we're just giving the input, the x, and the output, the y, the challenge is to figure out what's happening from one number to the next. All right, so for my first input and output, for 0 and 0, I don't really get a lot of information here. It doesn't really tell me much about what's going on. So I'm going to go ahead and skip that one and go down to the 1 and the 4. So I'm going from 1 to 4. So a couple of possibilities. And I'm going to write my possibilities in green because these could be either or. So it could be I'm adding 3, or it could be I'm multiplying by 4. So I've got a couple of options there. All right, let's go on to my next set of numbers. So I'm either adding 6 or I'm multiplying by 4. Okay, so maybe we have a winner here because now we've got 2 that are potentially multiplying by 4. So let's see if that's what's happening with the rest of them. 3 times 4 does give me 12, so that would work. 4 times 4 does give me 16, so that would work. And 5 times 4 does give me 20. And if I come back up here to the one that I skipped, 0 times 4 is going to give me 0. So I know that every single time I am multiplying x by 4 to give me my y. And I know that's hard for you guys to see, but I have seen some students write in the input-output table like this, and it really helps them to decode what's going on. So when I write my equation, when I write my answer, I need to write that y equals, because that's how we want to start all of our answers, is y equals x times 4. And I'm just substituting a little dot for the multiplication symbol, especially since I'm using x as one of my variables. The other thing I can do here is I can write this as y equals 4x, which just means the same thing. These two things mean the exact same thing. Y equals 4x means 4 times x. Now, I would encourage you guys to write this equation in this way, because this is how you're going to see it in the future. You may see this some, but for the most part, you're going to see it in this format. And again, both of these things mean the same thing. All right, we're going to go on to number 2, and we're going to go through number 2 pretty quickly because number 1 was a pretty easy one because it was a one-step equation. Number 2 is also going to be a one-step equation, so we're going to go through it pretty quick. We're not going to spend a ton of time on it because I want to save some time to look at a few of the more challenging ones. All right, so I'm going to go ahead and do the inputs and the outputs together, and I'm just going to write them down because if you have the companion assignment, you already have this in front of you. And if you don't, when I'm finished writing, you can just pause the video and you can copy down what's on the screen. All right, I'm going to slide it up so you guys can see. I'm trying to do this big so that you guys can see everything that's going on. All right, so I'm going to write my possibilities in green again. So I'm going from 0 to 5. So I'm either, well, I'm not either. There's nothing I can multiply by 0 to get 5. So that's really my only option, is that I added 5. Now when I get down here, I may find something different to make me realize, hey, maybe there is something I could have done here different. But let's see. All right, so 1 to 6, so I can either add 5. Oh, here we go. Got something in common. Let's do one more just for fun. All right, 2 to 7 plus 5. Well, I can't multiply a whole number by this. I could multiply a decimal or a fraction, but to be honest, I don't really think that's going to be what's going on, considering I already have 3 plus 5's right here. So let's check the rest of these. 3 plus 5 does give me 8. 4 plus 5 does give me 9. 5 plus 5 does give me 10. So clearly what's happening here is I am adding 5 each time to my x. And so the way I'm going to write that as an equation is very simply y equals x plus 5. Now you could write y equals 5 plus excuse me, 5 plus x. You could do that. There's actually a really good reason why this is a better way to do it. And frankly, it's a long, boring explanation, and it has to do with later on when you're doing some higher level algebra. So again, this is not wrong. This is okay, but this is probably a better format to go ahead and set this equation up in. All right. All right, so now that we're done with the easy ones, we are going to go to a two-step one. It should be a little bit more challenging. Okay. So we're going to do number 3. Again, I'm going to try to get all this on the screen so we can see everything that's going on. So my x inputs are 0, 1, 2, 3, 4, and 5. My y outputs are 3, 5, 9, 12, 15, and 18. I'm sorry, this actually should be a 6, not a 5. There's a typo on the assignment I gave out, so I'm going to redo my 8 there. That's not a very good looking 8, especially if you're copying this from the screen. That's a little bit better. Okay, so I know this is a two-step problem, and the reason I know that is because I wrote this assignment. But if you were just to look at this, some of the clues that you would get that this is a two-step assignment is my 0 here. I'm getting an output on my when I put 0 in, which means somewhere in some part I have to be adding 3 somewhere. All right, or adding something, because I can't multiply or divide anything and get anything other than 0. And I can't really subtract anything and get a positive number. So I've got to be adding something somewhere. Here my difference is 5. And here my difference is 7. And here my difference is 9. And here my difference is 11. And here my difference is 13. Interesting. Very interesting. So clearly I'm going up, but I'm not going up by any obvious factor. I can't multiply anything times 1 to get 6 that I would then multiply by 2 to get 9, because the only thing I'd multiply by 6 would be 6 itself. But we've already said, hey, I've got a 0 up here. So whatever I multiply is going to give me nothing on this, and this is going to give me 3. So I know that my second step is going to be to add 3. So whatever this equation is, I'm going to add 3 to the end. I'm actually going to go ahead and start writing my equation and just kind of fill in the pieces as I figure them out. So y is going to equal something, no idea what this is, plus 3. All right, and whatever this is, when I put 0 in it, I'm going to get 0 out of it. Okay, so because I know that I'm adding 3 to the end here, I'm going to go back and look at my outputs. And I'm going to subtract 3 from my outputs. Okay, now I think we might be onto something here. Because when I think about 1 to 3, 2 to 6, 3 to 9, 4 to 12, 5 to 15, those sure seem like factors of something. And they are indeed factors of 3. So I am multiplying by 3 and then adding 3 each time. 2 times 3 gives me 6 plus 3 is 9. 3 times 3 is 9 plus 3 is 12. 4 times 3 is 12 plus 3 is 15. 5 times 3 is 15 plus 3 is 18. So that's my missing piece, is I'm multiplying x by 3. So my final equation will be y equals 3x plus 3. Y equals 3x plus 3. All right, and some of you may have been able to see that without having to do this extra step. I like to show this because once I figure out, hey, I'm adding 3 on the end, I want to take that out of my outputs and see if I can see the pattern there. Okay. All right. Now, several of you, I promised in class that I was going to go over 4 or 5 problems, and I'm going to go over 5. And I'm going to skip now to number 6. I'm going to go ahead and skip to number 6 because that's going to set up the last problem that we're going to do, which is number 7. So we're going to do 6 and 7 to finish up. So number 6. Number 6 is going to be pretty easy for us to see the pattern, but it is going to set up what we're going to see for number 7. So my x inputs are 0, 3, 6, 9, 12, and 15. All right, now that's interesting because it's not following the typical 1, 2, 3, 4, 5, 6 or 0, 1, 2, 3, 4, 5 pattern that I've been using to this point. So that may be important. My outputs are 0, 1, 2, 3, 4, 5. Well, that's weird. I just talked about 0, 1, 2, 3, 4, 5. But those are my outputs, not my inputs. Interesting. Now, when my input is lower than my output, one of two things is happening. I am either subtracting or I'm dividing. One of those two things is happening for the input to be smaller than the output. I'm sorry, for the output to be larger than okay. Let's try this one more time. For the input, the x, to be larger than the output, then it's shrinking. The 3 is shrinking to a 1. The 6 is shrinking to a 2. The 9 is shrinking to a 3. So for that to happen, for it to get smaller, we're either subtracting or we're dividing. It's been a very long day. All right. Messed up my E and my Q there. So the question is, are we subtracting or are we dividing? Or maybe we're doing both. All right, so let's take a look. So for me to get from 3 to 1, I'm either going to subtract 2, or I'm going to divide by 3. One of those two. You know what? I did it in green earlier. Let me do it in green again so you can really clearly see the difference. Yep. Erase my 2. All right, so we're going to skip 0, 0 because, again, that doesn't really tell us anything. We will use that later, though, to connect whatever we decide we think is happening. All right, so 3 to 1, I'm either subtracting 2 or I'm dividing by 3. All right, 6 to 2, I'm either subtracting 4 or I'm dividing by 3. Oh, I think I see a pattern. Excellent. All right, so let's see if the pattern holds true. So I see 2 divided by 3s right in a row. All right, so let's see if that pattern holds. 9 divided by 3, hey, that is 3. 12 divided by 4, or excuse me, 12 divided by 3, hey, that is 4. 15 divided by 3, hey, that is 5. So it looks like my equation is going to be me dividing my input, my x, by 3. So my equation would read y equals x divided by 3. Now, another way to write this, and again, this is okay, this is correct, but another way to write this, just to kind of get you ready for some next level algebra, is to write this as a fraction, y equals x over 3. Because as we have talked about before in previous videos and in class, my fraction is a division problem. That this actually is a division problem. That's what all fractions are. This fraction bar is actually a division bar. So either one of these is okay. This one probably, though, is the better format to be using because this is how you're going to see this going forward. All right. Now, I want to go back real briefly and talk about the 0, 0. If we see an output of 0 and an input of 0, then we know we're multiplying or dividing. And we also know that it's probably only one step because we didn't add or subtract anything off the end here once we got that first step. So if we see the 0, 0 input, that's sometimes a good clue that it's a one-step problem and that you're either multiplying or you're dividing. All right, we are going to do number 7, and then we are going to be finished up with this particular video. Now, number 7 is the second hardest one on the assignment, and I'm not gonna tell you the answer for the hardest one because what's the fun in that, really? All right, so here we go. So my inputs for number 7 are 2, 0, 4, 1, 6, 2, 8, 3, 10, 4, and 12, and 5. Now this one's going to be challenging because there's not a definite pattern to it. There's not something I can just look at and say, hey, that's what's happening. Now the 0 is interesting because I'm starting with a 2 and I'm ending with a 0. So I'm going to have to remember that as we look at this. Now, one thing I do want us to look at is the inputs. There's a couple of things we should notice right off the bat. Number one, there's not a 0. There's no 0 input in this. So that could make this a little bit more challenging because if it's a multi-step problem, we're not going to be able to figure out what the second step is as easily. But they're all even numbers, and they're counting by 2. So that should tell me something right off the bat. There are no odd numbers here. Now, typically, if there are no odd numbers, or if we're seeing the factors of a specific number as my inputs, then that should tell me, hey, I'm probably looking at a division problem. Just like we saw in number 6. Because number 6 the inputs ended up being factors of 3. Well, number 7, my inputs, my x's, are all factors of 2. So whatever equation I end up writing, I'm going to be dividing by 2 somewhere inside of it. All right, so let's go ahead and just write y equals something. Well, we'll just leave it like this for a second. Let's because we're not quite to the point where we can really say this is what it is yet. All right, so if we use kind of the guess and check method, we've got the divided by 2. So if we divide 2 by 2, so I'm going to divide 2 by 2, that's going to give me 1. Well, how am I going to get to 0? Well, the easiest way is to subtract 1. So, and again, we're not really sure on this. So since we're not sure, let's write it in green. All right, so we're saying we're going to divide x by 2 and then subtract 1. Now again, this is a guess. We do not know yet if this is a guess. We do not yet know if this is correct. But I need to try something. All right, so this at least gives me something to attempt, something to try. All right, and I'm only on my first set of inputs and input and output. So let's go to the next one. So 4 divided by 2, that's going to give me 2. And then if I subtract 1, that's going to give me 1. Ooh. All right, but we've only tested two of them, so let's test at least one or two more just to make sure. So 6 divided by 2 is going to give me 3 minus 1. Hey, that gives me 2. So it's looking like this is going to work. So let's just, I'm not going to write these down because I know this is very hard to see anyway. But let's just go through this right quick. So if x is 8, then we're going to do 8 divided by 2. That's going to give me 4. 4 minus 1 is going to give me 3. All right, that works. All right, let's check the next one. If x is 10, then we've got 10 divided by 2 gives me 5 minus 1. That gives me 4. Very nice. All right, let's check the last one. So 12 divided by 2, that gives me 6 minus 1. That gives me 5. So my guess has just become my answer. So y is going to equal x divided by 2 minus 1. All right, now I had to check it against them all because the pattern wasn't obvious. And for some of these, that's what you're going to have to do. Now, the other way I can write this, and I want to show you this just to be consistent, is x over 2 minus 1. And again, remember x over 2 and x divided by 2, those are the same thing. All right, now I'm giving you a hint. If you've got the companion assignment, number 9 is very similar to this problem. All right, that is your big hint. Number 9 is similar to this problem. Remember, we had to look at the inputs and recognize that the inputs, they were all factors of 2. So on number 9, look at your inputs and see what they are the factors of.